So I'm Malti and I'll start off with the Spring Boot Actuator Log View Directory Traversal Attack. So it has a severity rating of 7.7, which is quite high. And we have the GitHub link here, which shows the commit. So we'll start off with the background. Now, Spring Boot is a Java framework that helps in creating production-ready applications that you can just run. The Spring Boot Actuator is another dependency that helps monitor the application using RESTful endpoints. It can give you information on the metrics and health checks and loggers or probably DB connections of an application that's running. The actuator log view is another dependency that gives you a log file viewer as an actuator endpoint. So when you hit the endpoint, you can view the log file in the browser. And it also has other features like listing the log folder content, viewing log archives, browsing directories, filtering, and so on. Directory traversal attack aims to access files and directories that are stored outside the intended folder. By manipulating the files with // it is possible to gain access to arbitrary files in the file system, like source code or configuration files or other critical files, and so on. So the Spring Boot Actuator log view dependency has an endpoint /log/view, which takes in two request parameters as inputs, file name and base. Now we also have a class called logViewEndpoint.java, which has a method called security check. Now prior to 0.2.13 version, the // was checked in file name and it was never checked for the base parameter. So if an attacker gave // in base, he or she could easily access an arbitrary file which included any confidential system file. Now this issue was fixed in the 0.2.13 version. So if you see here, we have the GitHub commit with the two parameters being checked. We also have an interactive representation of this issue in the next slide. So this is a D colon with a bunch of folders. The temp folder is generated by the Spring Actuator log view, and it has a file that collects all the logging information, the startup logs and the console info logs and debug statements. So all of that is collected in the spring.log file. And we have a system folder which has a password subfolder, and this is just to replicate a dummy confidential file. So any unauthorized access should be prevented to this file. So now we will go back to the application. It's a Spring Boot application and it's being started in the debug mode. And if you see here, this is the dependency, the actual library. And if you see here, the version is 0.2.12, which is the deprecated version of Actuator log view. So this version has the actual directory traversal vulnerability. The YAML file, it's where the log path is configured. So that's mentioned here. Now we go back to the browser just to verify. If you hit this endpoint, we get the spring.log file. We can visually search any text and a match will be shown in the browser itself. So it comes in handy if your log file is pretty big and you want to search for a particular exception and you can't go through a whole file. So that's the whole purpose of the library. Now this is where the vulnerability comes into picture. So if you see here, the parameters have there are two parameters. One is file name and the other one is base. So the file name has system/passwords as the value, and the base has ellipses as value. So what we try to do here is, using the base parameter, we try to exploit this library and get access to the personal folder. So as you see in the D colon, we have the system passwords at the personal folder, and we'll try to gain access to it. So now I will hit this URL and put the application in the debug mode. So now I've put a breakpoint at this method called security check. It's a method that's inbuilt in the library. So it sure does check for the ellipses in the file name parameter, but it does not check the base. So that was a vulnerability here because we added the ellipses in base, but this has been checked in file name. So now what happens because of this, we get easy access to the personal folder in the D colon. So if you see here, we have gained access to the confidential data. So now this issue was rectified in the 0.2.13 version. So now we'll switch to the 13 version, and we'll see how it works. So the application's restarted, and now we do a small verification. If the library has been added, it shows up. Now we try to exploit the vulnerability. The same path is given, the base is given. Now if you hit the URL, it shows a white label error page. So this means that the error or the vulnerability was fixed in the 0.2.13 version. And it also shows an exception that this user data.txt may not be located outside the base path temp/log. So this solves our issue.
Hi everyone, my name is Kamal Preet and today I'm presenting the final project where the author has secured the exploitation of confidential information by using the explicit intents and introducing a new Java class with secure REST API calls. So let's start off with the objective of the research. This bug is based on an Android application where the hacker tries to manipulate the data by using put REST API calls. Here, the vulnerability is that in the device, any application can open or access the data, which will impact the devices that has applications downloaded from sideload that are not secure. So the vulnerability allows the hacker to use gift card by using a put request. The objective of this research is to show how hackers can copy the application data and manipulate it if encryption is not used. After manipulation, they can use the API calls to change or create the entry in the database and can use the gift card which does not belong to them. Also, we will see how we can secure the application by using the intent type and introducing a new Java class that is product scrolling activity within the application so that other applications cannot use the same cookies. Also, here we have used HTTPS to secure the communication for all the API calls. I have added the GitHub links in the slide which shows the commit. Now, let me give you the overview of the project background. Here, I'm describing three security issues that are listed in this project. The first vulnerability allows the hacker to copy the application data and cookies and then manipulate it, as most web-based applications use cookies for session handling. The second security issue is APIs are using HTTP protocol instead of HTTPS, which makes it easier for the adversary to decrypt the data. The third issue allows the hacker to create or use any gift card using a put request. So, we will explore Android security by delving into intents, using secure API calls, finding vulnerabilities in design, and making the application secure by removing the unnecessary data collecting codes and updating the application. My vulnerability type is cross-site scripting, which is known as XSS. It is a type of vulnerability that is commonly found in web-based applications. This vulnerability makes it possible for attackers to run malicious code into victims' web view through HTTP client API. Using this malicious code, the attacker can steal the victim's credentials. In this slide, the commit shows how a new class has been added to stop cookies to use in other applications. Let me first give you an introduction about the intents. Intent in Android is used to perform an action on the screen. There are two types of intents, explicit and implicit. In explicit intent, we can clearly target the activity that handles our intent, while the implicit intent broadcasts the request that any application with the capability can take up. If I talk about which one of these two intents are more secure, then the answer is explicit intents. Explicit intents are more secure as we have more control over the execution as opposed to implicit, where we never know how our request is going to be handled. So on the left hand side, the code shows how the application is requesting to use any other application on your device that supports opening these type of links, which allows the sensitive application data to get shared in any supported apps. In this slide, in the line number 69, an implicit intent has been shown, which then has been fixed by explicit intent. It happened by calling the API index implicitly, while there is a way to do it explicitly through product scrolling activity that renders the API response into an activity. On the right hand side, you can see the issue has been fixed by introducing the correct intent type, with introducing a new Java class that allows the application to open a browser within the application. In this slide, the author has shown the updated XML file where he has removed the intent filters, which are highlighted in red color on the left-hand side. The reason intent filters has been removed because they help in resolving intent manipulation security issue in the application. By using specifically designed intents according to the actions mentioned in intent filters, an attacker may be able to transmit sensitive information to the third-party software on the device, or an attacker could run his own code using the application which is not authorized to run from outside the application. In this slide, we are encrypting all REST API calls by updating HTTP to HTTPS for a secure communication. The security benefits of using a secure communication via HTTPS includes authenticating the server, encrypting data transmission, and protecting the exchanging from tampering. On the left-hand side, you can see all the insecure REST API calls, and on the right-hand side, they have been fixed by using the HTTPS encryption. The author has mentioned in the bug description that when he tries to run the first token, he can only use cards that belong to him which are unused. However, he mentioned that by using the other two token commands, he can use those cards that does not belong to him. This vulnerability allows every user to use any gift card using a put request. This can be fixed by associating cards with accounts and enforcing a policy so that only those who own the cards are able to use them for transactions. It could be as simple as adding a user field so that when someone tries to use the card, the system checks if they own it or not. These tokens run on the server side. And here are the references. Thank you.
Hello everyone, this is Neeraj Kumar. Let's get into the presentation now. So what is Log4j in Java? It's kind of a Java-based logging utility developed by Apache's Software Foundation in January 21, and the license owned by Apache License 2.4. So some of the benefits are here. It's open source and freely available and helps understanding and debugging the runtime behavior of the programs. It provides sufficiently rich logging package, can also be viewed as an auditing tool. And the most important benefits are the Log4j provides different built-in log levels so developers can log message depends on the scenario. Yeah. So what is a Log4j vulnerability when it was found? The security researchers in Alibaba, the Chinese largest e-commerce company, the first reported the vulnerability to the Apache Foundation on November 24. So there are many vulnerabilities in Log4j. Here we're going to talk about the 44228 called the remote code execution vulnerability via LDAP JNDA parser. So the Log4j version less than equal to 2.14.0 are subjected to remote code execution vulnerability via the LDAP JNDA parser. So before getting to this vulnerability, you have to understand basic three terminologies. The first RCE, it stands for remote code execution. So what this means is this actually allows the attacker to able to run any code on your machine by hacking into your application which exposed to the vulnerability. Yeah, it takes control over your application. And then the JNDI. JNDI stands for Java Naming and Directory Interface. It allows you to store Java objects in a remote location and then serialize them and streaming them to your JVM. And the final is LDAP, is an open source cross-platform protocol. LDAP use case is serving as a central location for storing authentication information such as username, password, and you can use the stored authentication information on various applications to validate your users. So let's this simple diagram explain this vulnerability very easily. Here your vulnerable app or any online retail shop. Here is the adversary, and here the legitimate LDAP server and the followed by malicious LDAP server. So attacker pass or search in the request which contains a JNDI URL regular expression string. The application takes the string as an input and might not get any search results, but what the application does, it tries to log and Log4j is going to look at the URL and it's going to make a JNDI request to the malicious LDAP server and they return back to the serialized malicious object. So nobody knows what kind of program it could be, anything such as malware or virus as a Java object. So attacker have ability to put a malicious Java object into the JVM of popular e-commerce website and able to instantiate the malicious Java object and will have a control over everything. That's referred as remote code execution. let's look into the bugs reproducing and how is gonna fix that one. So as you can see here, I defined some variables. Every variable has some string values. So in the location one, I stored the Warsaw, and right now I declare the log APIs. I'm trying to print the location one value in the log statement. So I'm just running the program now. So as you can see here, yeah, yeah. So we got a input, the output like Ontario Tech University located at Warsaw. It just printed as a string, as an info statement. So right now I'm, instead of location 1, I'm changing to location 4. The location 4 has the same string values, but here it just pointing to some LDAP server. Yes. So what the logger is going to be do, this is a vulnerability in this log4j, right? So it's trying to do the JNDI lookup for this LDAP server. Yeah. So the LDAP server, it could send any malicious Java object to this JVM. So right now, as you can see here, this logger API did the JNDL lookup. Yeah, it's supposed to print that string as a normal text in the console, but instead of that, it's did the JNDL lookup on the LDAP server, and it's, yeah, it could download any malicious object to this JVM. This is what the vulnerability it just found in log4j less than 2.14. Right now I have a log4j 2.16. The same variables I'm just gonna print, it has a fix right now. So as you can see, the same JNDA LDAP string, it's not looking for any JNDA lookup. Yes, it's just printing at the same string JNDM LDAP string as a text in the console instead of doing any JNDA lookup on the server. That's what the fix. For the cybersecurity form checkpoint, over 8 lakhs exploitation attempts were detected in first 72 hours after Log4j issues become public. Simply because 95% of the Java program using Log4j library. There is a security development company called Snyk did the scanning of around 39% Java program directly and 60% of indirectly using the Log4j dependency. The widespread impact of this vulnerability is so large that it may take years to fix. There are primary open source projects heavily impacted by this vulnerability. As part of the mitigation, as I already shown in the demo, that using any Log4j library 2.16 version or more than that could protect your application being hacked. Here is the official fix commit from the Log4j developer team. As you can see here, there are no longer supporting JNDA lookups by default in the library, and moreover you can manually disabling these properties to protect your application from this vulnerability. Here bugs tracking pages where you can get whole history of when this bug was created and committed so far, and here are the references. Thank you.